Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 2873. Maximum value of an ordered triplet 1. This problem is based on array and will go greedy in this case. Also this is asked in media.net and marked as easy. Now let's have a look on the problem statement. Here we are given a 0 index integer array nums. And we have to return the maximum value over all the triplets of indices I, j and k such that I is less than j and j is less than k. We have to pick 3 items I, then j, then k without any duplication, one after another. And if all such triplets have a negative value, then return 0. It means we only have to return any of the positive value, which is the maximum. If we don't have any positive value, then return 0 in this case. The value of the triplet of the indices I, j, k is equal to nums of I minus nums of j into nums k. So this is the formula we have to use to find the value of the triplet. And among those value of the triplets, whatever is the maximum value, just return that. If the maximum value is negative, return 0. So this is our problem statement. If I just have a look on the constraints, nums.length will go till 100. The nums is of 100 size at max and the value can go till times power 6. So if we are using multiplication, it might overflow. So in that case we'll be using long. And for the nums.length, the constraints is very low. So to pick these 3 elements, we can either use iteration, nested loops, three nested loops. Okay, now let's come to the example. First one is what is given to us. Given is a 0 integer array nums, and these are the array elements. 5 elements are there. We have to pick 3 indices. First one is index I, then index j after index I, then index k after index j. I is less than j, j is less than k. So if I just pick these 3 elements, let's say if I pick 12, 6 and 1, the value of this triplet will be the value at index I, that is 12, minus value at index j, which is 6, and this value multiplied with value at index k. So it will be 6. So this is the value of the triplet. And if I check all the possibilities and whatever the triplets we are getting, we have to return the maximum value. If I just try to analyze, I can have 12, 6, 2 as well, 12, 6, 7 as well. So all of these values are going to give me different values. But here in this case, we have to maximize this value. Nums of I, if I just try to write it, if nums of I write like this, nums of I minus nums of j into nums of k. This value I have to maximize. If I have to maximize this value should be maximum, this value should be minimum as possible, and this value should also be maximum as possible. And we are already given that we have to pick all 3 items in order. Okay, so these are the points to be noted. This is to build our intuition. And in this case, if I just try to see whatever is the maximum value of I and j and k I can have, if I just pick 12 as I, and j should be minimum because j is a maximum, minus j with a minus sign. So for j, if I pick 1, it would be giving me the best result, and this is for the k. If I pick indices like this, let me change the pen. If I is this, j is this, k is this, then value at I is 12, value at j is 1, into value at k is 7. So 11 into 7, 77. So this is the maximum value I can get. I don't see any other option to get a maximum value. Now this is something we have to return. If let's say all the elements are negative, or maybe this I'm getting all the triplets value I'm getting as a negative value, in that case they are saying that if you are not getting value greater than 0, then return 0. It means all of these values I'm going to pick I'm going to capture in the maximum variable. That maximum variable I can initialize with 0. If I'm getting greater than 0 value, I will update it. Otherwise, I don't update it. Okay. Now I hope the problem you have understood perfectly, and let's have a look on the approaches. First approach. What can be the brute force for this? Brute force would be I have to first pick I, then pick j, then pick k. Firstly, I pick using a for loop, then j, using for loop, then k. 3 nested for loops. And why I'm talking about the for loops? Because the constraints are not that high. 10 to the power 2 into 10 to the power 2 into 10 to the power 2. 10 to the power 6 in total. I can easily go with the looping. So for first loop, I will be initialized with 0 and it will go till how much element? See, let's say if I am having 5 elements, 0, 1, 2, 3. All 3 elements are different. Let's say this is the k and this is the I and j is in between. So I can go from index 0 to n minus 2, less than n minus 2, because if to keep it simple, I will go till n minus 3. Why n minus 3? Because if it is going till n minus 3, there should be one element for j, that is n minus 2, one element for k, that is n minus 1. So I will go from 0 to n minus 3. Correct. Then what about j? J is starting from I plus 1 and j is going till n minus 2. From I plus 1 to n minus 2. And what about k? K is j plus 1, because k we have to pick after j, and k will go till n minus 1, till the last element. So using these 3 loops, we are going to have all the possibilities of I, j, k, and I can capture this maximum value. Maximum value is equal to whatever is the maximum I have encountered so far minus this formula. What is this formula? Index I minus index j into, but I have to typecast it to long, index k. So this is the formula. And what is the time complexity of this formula, or maybe max operation? So this operation is order of 1 time. What should be the initialized value of max? In the problem statement it is given that if you are getting a negative answer, just return 0. So initialize it with 0 instead of minus infinity we usually do. Okay, so this operation is order of 1 time, and this loop will go around order of n time, around order of n, around order of n, n into n into n. So the time complexity in this case will go n cube. And what about the space? Order of 1. You will be able to submit the solution over the LeetCode because the constraints are not that high. And yeah, at least try to submit it, because these conditions where the looping with the indices are going, so starting to ending, this is also useful. And this typecasting, you have to take care of this typecasting. It means that this long max variable you have to take as long. Now this is our first approach. You will be able to see the code in the attachment in the description below. Now let's directly come to the approach 2. Approach 2 that came to my mind is something I got an idea from this formula, I, j into k. So this is the formula that I need to maximize. If you have to maximize this formula, and the other thing is you have to pick items in order, right? If I just directly ask you what can be the possibility of this j? J can start from index 1 and j can go till index n minus 2. So this is the range for j. And if this is the range for j, what is the value of I should pick? Whatever is the maximum on the left side. Maximum from the left side. And for k, maximum on the right side. R maximum. So whatever element I am having on the right side, that is maximum, I'm going to pick that. Why? Because these two elements are contributing positively and only this j item is negatively contributing. So just try to pick items in a greedy fashion. Try to pick the maximum value of I, maximum value of j, and I'm damn sure that I should be less than of the j, left side of the j, and left side of the right side of the j is k. So j range will go from this to this, that is around n possibilities. And if somehow I am able to get these two values in a constant time, if somehow I am able to get these two values in a constant time, I will be able to get the overall solution in order of n time, right? But how I can get these two values in a constant time? See, there is only one word answer, that is preprocessing. Preprocessing. We do preprocessing in a lot of cases, like prefix sum we used to do. So here, whatever is the example, just directly come to that. 12, 6, 1, 2, 7. 12, 6, 1, 2, 7. So this is my array. And for every element, what I need to know is whatever is the maximum element on the right side. Let's say I am taking two arrays. One array is left maximum and the second array is right maximum, right? And what is my range of j? J will start from this and j will go till this. Start from index 1 will go till index n minus 2. Now okay, I can pick the value of j using a loop. Here the range of j is going from 1 to n minus 1. Let's say I am starting with 1. What value I should require? I should know what is the maximum value I have encountered on the left so far and what is the maximum value on the right. So this is the range. This will define the range, and the j value will go from starting here, and at the last moment I should know the right maximum of this and the left maximum of this. It means that the left maximum will go these three places. I am writing tick marking using blue, these three places, and the right maximum will go these three places. I require these elements actually. If you are not able to understand it, you can skip it. Just a minute, I am cleaning it out. Let's clean it and let's have this borderline. Let's just directly capture the left maximum. See, for the left maximum, there is no element on the left side of this. It should be right, 12. For the right maximum element on the right side of 7 is 7. Including 7 is 7. Okay, now let's run the loop. Left side, maximum element on the left side of 6 including 6. So whatever maximum we have captured, comparing with this, it will be 12. It will be 12 again. It will be 12 again. Right? You can decide the loop. You can fill the element as per your need. And for the right maximum on the right side of the 7 including 7, there is 7. It is also 7. It is also 7. And it is also 7. Right? So in this case, when I'm coming to 6, the left maximum is 12 and right maximum is 7. When I'm coming to 1, it is 12 and 7. In all the cases it is coming as same, but it won't be the case for all the other examples. See, so in this case, my j value will go from 1 to n minus 2. From 1 to n minus 2. So it means my left maximum I can have from 0 to n minus 3. 0 to n minus 3 for left maximum, and the right maximum, so 0 to n minus 3. So these three value will be used, because this won't be used because at least two elements should be utilized for j and k. Same for the right max case. Right max value will start from n minus 1 and it will go greater than equal to 2. 0, 1, 2. Yeah, 0, 1, 2. This value is not required because these two elements at least for I and j. So this is the range for left max, right max. These value we can fill using any formula. First of all, I will be taking a left max array, right max array of the same size. And then what is the value of the left max? See, to initialization, left max 0 will be numbers of 0, and right max n minus x will be nums of n minus 1. Now you can run the loop. Instead of 0 is already filled, 1 to n minus 3, n minus 1 is already filled, n minus 2 to greater than equal to 2. So for loop I equal to 1 to n minus 3, right? So left max is equal to maximum of left max we have encountered so far, left max I minus 1 comma nums of I. This will be the formula. And for right max, this value will go from n minus 2 to greater than equal to 2. So right max is equal to maximum of right max we have encountered so far for n minus 2. See, j, let's say the variable is I in this case, so it will be I plus 1, right max of I plus 1 comma nums of I, whatever is the maximum value. And when I have to pick j I will be picking, for j what I can do is, value at j is see, the value of range of j is 1 to n minus 2. Let's say j is at this position. For j left max I can find out at j minus 1 value, and right max I can find out is j plus 1 value. So this formula I can use to figure out the answer, and this will be done in order of n time, but here we might also require space to capture the left maximum and right maximum. Now let's code this approach. Here, as part of first solution, I have written this nested loops, 3 nested loops to get the answer, because the constraints are not so high, length is going till 100, so I can directly use 3 loops. But we can save the time by doing some kind of pre-processing, as we decided, by pre-computing the left maximum and the right maximum. So let me code that approach. First of all, just capture the length of this variable, and I might require 2 arrays to store my left maximum and right maximum. Lmax is equal to new integer of size n. What is R maximum? R maximum is also new integer of size n. I need to fill these 2 values. See, I equal to 0, I less than equal to n minus 3. I will go till n minus 3. There is no need to go after that, because after that there will be space for 2 other elements, j and k, as we have to pick all the triplets I less than j less than k. Okay, this is the loop I plus plus. This loop is to capture my left maximum, and I also writing a loop for capturing the right maximum. Int I equal to n minus 1. I need to find the right maximum of n minus 1, and I greater than equal to 2. Index 0 and index 1 I'm skipping. 2 element I'm skipping for this I and j. So I'm currently finding the maximum of k. Here I minus minus. So this loop is going to be helpful to figure out the right maximum. And there is one more thing I need to discuss. See, I equal to 0. That is for the current element. For the first element in this nums array, what is the maximum element on the left side? There is no maximum element on the left side, including this element. That is 12. So here I can do some initialization as well. Lmax of 0 is equal to nums of 0. If it is the case, there is no need to start it from 0 now. Start it with 1. Similar to the Rmax. Rmax of n minus 1 is equal to nums of n minus 1. What is the maximum element on the right side of 7, including 7? That is 7. So in this case also, I don't need to check for the n minus 1. I just have to start with n minus 1 minus 1. Here, what are the other values? Lmax of I is equal to math.max Lmax of I minus 1. Whatever is the maximum element I have encountered so far, comparing with the current element, is the left max. Rmax of j is equal to math.max Rmax of j plus 1. Whatever is the maximum element you have captured so far, comparing with the current element, is the maximum element on the right side of the current element. I hope you are understanding what I am saying. Max of j. So our pre-processing is done. See, this pre-processing is taking order of n time, but this is saving us time from order of n cube to order of n. Now what is my result? Result is a long value 0l semicolon 4, and for the result I am iterating for the value of k and value for index of j. Index j, there is at least one element on the left side, one element on the right side. It means that is going to start from index 1, I less than n minus 1, I plus plus. See, this I, j, k, these all are indices. There is no need to have a different name. It's all index value. So for j, I am just calculating it, and what is the result? What is going to be the result? Result is the math dot maximum of result so far. Now my formula. Now I'm writing my formula, and whatever is the answer, just return that. Formula is, for any current element, just figure out what is the maximum element on the left side. Maximum element on the left side of I minus current element multiplied with maximum element on the right side, or maximum I plus 1. But here I just need to do typecasting too long, because integer into integer is integer, and that might go overflow and returning some garbage value. To avoid that, I'm typecasting it and storing the result in this result log. I think let's just directly run over sample test cases to see if the code is fine or not. I am having one compilation error, and this compilation error is, see, the iteration variable is I. Why I am using j? Let's test over all the cases. It got submitted successfully, and it beats 100% of the Java solutions. Now I hope you understood the approach. When I submitted the above one, it gave me around 60% faster. But in this case, because of the lower size of the nums, I am able to use it. So this problem is to teach us how the pre-processing is helping us save time in the program. Okay, I hope you understood everything. Thank you guys. Bye bye. In case you get any doubt, you can have a discussion in the Discord community attached in the description below. Thank you. Bye bye.